In this video, we will be solving this difficult looking question, that is sigma from R1 to 2025 R square 2025 CR upon sigma R into 2025 CR. The limits range from 1 to 2025. Numerator can be written as sigma R equal to 1 till n R square NCR, and the denominator can be written as n R equal to 1 R into NCR. In this question, n is 2025. Now we will solve this first and then we will move on to this question. Starting with the denominator, we have sigma n R equal to 1 R into NCR. We will just put in the values of R equal to 1 or the values of R from 1 to n to see how the series goes on. Putting the value of 1, we get NC1, 2 into NC2 plus 3 into NC3, and this goes on till n into NCn. Now we also know that the expansion of 1 plus x power n can be written as nc0 into x power 0 plus nc1 into x power 1 plus nc2 into x square, and this goes on till ncn into x power n. Now the method to form this equation from this is to differentiate this equation with respect to x. Now why did we think of this is because on differentiating this term we would get 1 here, and that would result in nc1. When we differentiate this term we would get 2 into nc2, which is this, and similarly on differentiating the last term we would get n into ncn. Differentiating this equation with respect to x is n into 1 plus x power n minus 1. Now this is a constant because x power 0 is 1 and nc0 is also a constant, so this will be 0. Differentiation of nc1 into x is nc1 plus differentiation of this is 2 into nc2 x. Differentiation of the next term will be 3 into nc3 into x square, and this goes on till n into ncn into x power n minus 1. Now putting in the value of x as 1, we would get this sum, that is n into 1 plus 1, that is 2 power n minus 1 is equal to nc1 plus 2nc2 plus 3nc3 till n into ncn, and we had to find this sum which we got as n into 2 power n minus 1. So I will erase this and write this directly as n into 2 power n minus 1. Now that we know the value of this, we will try making this in this format, or however the summation proceeds. N upon R equal to 1 R square into NCR. To make this in this format, I thought of this formula, NCR equal to N by R upon N minus 1 CR minus 1. Now when we multiply R here, we get that R into NCR is equal to N into N minus 1 CR minus 1. Now here we have 2R, that is N R equal to 1 R into NCR. Now I wrote this R into NCR as N into N minus 1 CR minus 1. since n is a constant, this can be taken out of the summation, and the sum can directly be written as r into n minus 1 c r minus 1 here. Now this can be made in this form, but how? Let's write, let's add and subtract 1 here, so that we get r minus 1 in product with this, that is n sigma n r equal to 1, n minus 1 c r minus 1 as it is, and minus 1 plus 1. Now this can be written as sigma n r equal to 1, r minus 1 n minus 1 c r minus 1 plus n minus 1 c r minus 1. Now taking r minus 1 as some another constant k to make this in simpler form, r minus 1 is equal to k. This can be written as n. Here k would be 0 because r minus 1, when we put r as 1, we would get the initial value of k as 0. K into n minus 1 ck plus, I am distributing or separating these two terms, n r equal to 1 n minus 1 cr minus 1. I am writing this in terms of r. Now the one thing that we should take in mind is that the last term of both of these summations would be n minus 1 cn, but we know that in the general formula NCR, r is always less than equal to n. So we will change the limits of the summation, that is we will remove the last element of the series, because the answer would be 0. Now we have the first summation of this format, where n is replaced by n minus 1, n into, here we have n minus 1 in place of n, so the answer would be n minus 1 into 2 power n minus 2. Now for this series we have, now we will substitute r minus 1 as k here too, because we would get the summation nc k from k equal to 0 to n minus 1 or n minus 1. K is equal to 0, n minus 1, n minus 1 ck. We have 1 plus x power n is equal to nc0 x power 0 plus nc1 x power 1 until ncn x power n. When we substitute the value of x as 1, we will get 2 power n is equal to nc0 plus nc1 till ncn, and this is the same as this, but we have n minus 1 in place of n, so the value of this sum will be 2 power n minus 1. Sigma n r equal to 1, r square ncr is equal to n into n minus 1 into 2 power n minus 2 plus 2 power n minus 1. Now taking 2 power n minus 2 common from both the terms, we will get n into 2 power n minus 2, n minus 1 plus 2, that is n into n plus 1 into 2 power n minus 2. Now that we have the value of both of these summations, let's divide this by this, and afterwards we will substitute the value of n as 2025. Now this was the numerator, this was the denominator. So on dividing, we will get n into n plus 1 into 2 power n minus 2 upon n into 2 power n minus 1. And n is getting cancelled, and this is and 2 power n minus 2 will be cancelled by 2. So the answer is n plus 1 by 2. Now putting the value of n as 2025, we will get 2025 plus 1 upon 2, that is 2026 by 2, or this is equal to 1013.